Good afternoon, everybody. I'm Catt, Latham High-Tech Seed, the corn silage specialist here. We're going to be working on some corn silage yield estimates here today. So we're going to be coming from the field all the way back up here where we process the samples and get a yield estimate. So we'll be walking through the steps and the procedure and how we do that here at Latham High-Tech Seed. Okay, so now we're in the field here. We're going to get a sample to bring to do a yield estimate. One of the most important things of getting a sample is getting the right distance between plants. So as we go into the field here, we're going to be looking at the distance and spacing in between plants. So we're in a test plot right now. We've got about 24 different varieties, so it's really important to find that real consistency, so we reduce our amount of variability between reps. So I use a regular garden shears, and then I actually cut between 14 and 16 inches off the ground. And I ask the farmer generally how their chopping height is, and then we use what their chopping height is, and we remain consistent from every sample, again reducing that variability. So now we're going to step in and we're going to get the sample. So as we enter the field, one of the biggest things we're looking for is the consistent spacing in between plants, and we're looking for 4 that are equally spaced apart in order to obtain our sample. We're in a specific hybrid called 5742, so then I just write on my piece of paper the hybrid number, 5742. I just use this, and then I look up here at the ears, and I make sure all the ears are consistent across our sample that we're gonna take from. I take this and I'll slide this in, and then we use that to identify the one we're going to use for a sample. The next step is to measure in 14 inches. And it's really helpful that if you have another person with you that can help you hang on to these, because we really don't want them to touch the ground or not get any soil on the bottom side of this. So it's really careful. This piece right here is really absorbent, and it'll get some soil in it. Sometimes that'll change the ash content and the fiber digestibility component just a little bit. So we want to be really careful about that. So, and then 14 inches. And if the 14 inches lies on this node, then I'll go just slightly above the node. I won't include the node in. Okay, so for this particular area of the field, the next step is to get the GPS coordinate of where we've actually got the sample from, and that's really an important component to that. So I've got a Garmin Glow that I use to get a really accurate GPS component. And then we use the Cirrus app here at Latham High-Tech Seeds, so on the phone here, so we can just find out our location right here. We're 44.6504 latitude, and then negative 92.2823 longitude. And that's the sample where we're getting this. So we know exactly where it's from. And then the next step that we'll do is actually take a soil sample. That's the future where we're heading here now, is to take a soil sample and then pair that all together from the soil all the way through the sample and look at the interaction between all of that. So as you can see right here, the distance in between each one of these plants, it varies slightly, and sometimes this spring it was a little bit wet out there, and the Keaton seed firmer actually drug a little bit of the seed along here, so you can see that there's a little variation. So we're at 4 inches of spacing here, and then we're back to where we're at, right around that 6-inch mark for the rest of these. So, so we wanted to make sure that the sample was right at that 6-inch mark. And even though the rest of the population is at 35,000, I've got a grid that I use right here that can actually determine at that 6-inch mark, and it actually is 34,500 plants per acre is that 6-inch mark. So the sample was taken from that. So this is kind of a double check, because if we sample this 4-inch mark right here, that equivalent of 4 inches is going to be a lot different. You're going to be down to that 51,000 plants per acre equivalency. So it's really vital that we make sure that we're at that equal distant spacing, because that affects the fiber component, and it also affects the repeatability of the samples. So that's really an important thing, is making sure these are equal distant as best we can. So one more thing to do, and then if this isn't a large field, with the GPS coordinates, we'd like to replicate this over several different areas of the field to get a better average. So that this is just one rep, and then we would do a second rep also with the GPS, and I tend to like to do at least 3 reps. It gives us a pretty good idea, and the repeatability is pretty good, and it's very close to what the chopper and weigh wagons would be going through here. What the nice advantage of this is, this system especially, is today, if you notice, it's really wet, and we've had a lot of rain over the last few days, so the choppers actually wouldn't be able to get in here, and we're at half milk line today, and we really needed to get this out of the field, especially to get the best data that we can. So this protocol has enabled us to actually be able to get the right timing and get the right harvest for the corn silage to get the best results, so the farmer can make the best decisions with this information. So it's really important that we look at that half milk line and get close to that 65 to 70% whole plant moisture. So that's where we're at here today in the field, taking a look at on the acre here at Latham High-Tech Seed. One more thing I want to point out, as we're in the field here, you can see that there's a big gap right here. This spring we did have a lot of rain, so water was pooling right here, so we didn't see a very good emergence pattern right here. But the interesting thing about that is this particular plant right here, that the ear is flexed out quite a bit on it, for one thing, but the fiber component is going to be more digestible because it's not competing against the neighboring plants. But when we come over into this situation, if you remember, we measured this was about that 4 inches apart. These plants right here, the fibers are going to be elevated, because one of the things in the corn's life cycle is that it wants to reproduce. In order to reproduce, it has to stand. In order to stand, especially in these tight, when they're competing this closely against each other, it'll actually lignify more at the base. So the lignin component will increase at the base of the plant. So in order for it to stand, and that lignin is a structural component of the plant, and it's housed around the outside and interacts with the middle, and adds a lot of strength to the plant, but it has a negative impact on digestibility of the fibers. So a lot of research has been done on this over the years, and I've done a lot of research as well in row spacings and actual plant distribution. So we've got a lot of great research that you can follow us here at Latham High-Tech Seed. So just as a review, corn silage, 50% of it typically is a grain, and then the other 50% is roughly stover. So if we remove the grain out of this corn plant right now, so we'll extract that, this plant here alone is going to be roughly right around high 70s to 80% moisture. And then we're at about half milk line with this grain. This is half milk line, if you can see that. It's kind of hard to see right now. But we're at half milk line with this, and so when you blend these two together, this is going to get you about 65 to 70% whole plant moisture. As that milk line drops and gets more toward 3/4 or past the half milk line part, our variability in the field gets less and less. So they always say when you do a Koster crop tester check, that to add about at early season you want to add 2 to 3 points, because you'll pick that up in the field. Part of that is because in the spring we got some variation in our emergence, so we have a different maturity in the field once in a while, just based on that variation, and from the planter or from the season. Like we had this year, it was a very, very cold spring and it was wet. So we saw a lot more variation, but as that milk line drops down, we get a little bit more consistency, and we maybe pick up about 1 to 2 points as that milk line drops. And then The other thing is that corn silage will dry anywhere from a half a point to a point a day in the season. As this milk line drops down and as the air temperature changes, we'll see that milk line drop pretty fast, or the plant will change in moisture pretty darn fast. So it's something to be really mindful of, especially if we got all the moisture that we need, all the nutrients in the soil, and the plants are really happy. That milk line will move fairly fast in those good temperatures out there. So like today now, it's fairly cool out there, so we probably won't see a lot of milk line movement here today, and then it's a really damp day out. So the other part is we're not going to lose much moisture. We won't see much moisture change here in the next couple days. So so that half grain to stover is really important. So about 50% of that, and that's why we measure the grain to stover ratio. That's kind of an important component to know. And then that reflects back in our data report, and we'll be talking a little bit more about that later on, but it's a non-fiber carbohydrate, and that's the starch that we find inside the kernel, and some of the sugars that are in the stock is part of that non-fiber carbohydrates, and we'll be finding that in our report. And usually we want to see that number right around 50%. And as the starch number increases, or the stover becomes less, you'll see that the NFC level, or the non-fiber carbohydrates, will increase. Also, as the milk line drops and and we get a lot more dry starch in there, you'll see the NFCs increase as well, because sometimes the stock is drying out and we actually have 60 to maybe 65% whole plant moisture. So the NFC levels will increase because there's a lot less moisture. Sometimes the plant might get a little bit diseased or something, and we lose some of that moisture that's in the plant itself. So also we're going to talk about some things that I like in corn silage. I really like a healthy plant. That's really important. So as we look at the plant here, we look for that greenness all the way up, and we look for that intactness. We like the tassel intact. Plant health is huge, and part of plant health is keeping the molds and mycotoxins and disease out of the plant, and it keeps it out of the bunk. So the healthier the plant we have, the better off that we are at the bunk and in the forage for the animals. So I really like very disease tolerant varieties, and especially to leaf diseases. So with the application of headline amp, we've seen an average of about 3 more ton to the acre. So that's pretty significant, and that's an average. So headline amp is really something to think about. I know it's an investment, but your return on investment is kind of a little bit better when you think about keeping the leaf diseases off and keeping that plant as healthy as you can, and then the impact that you have at the bunk. And that's the part that we're thinking about, is keeping this forage as healthy as we can all the way into the bunk. So another thing that I like white cob hybrids. White cobs, the digestibility tends to be a lot greater in the white cob, so it just makes a nicer forage. We don't see as much bunk refusal with the white cobs. It just blends up so much nicer than red cobs, and it works very nice. So our leafies, like 5062, is a variety that has a white cob in it, and it's a very large plant, and it grows, gets some excellent tonnage, especially in our North Dakota regions. We see some great tonnage with our leafies, our 4542 and our 5062 varieties. So another thing I just was going to point out is the milk line. Again, we're shooting for that half milk line, and here's an ear that has a nice contrast right now, so we can really see that milk line differential right here, and we're at true half milk line. And so the variety that's mixed in with right now will be roughly that 65% whole plant moisture. So when we're doing any test plots, any corn silage plots, I try to find the middle maturity variety in there that is at half milk line, and that's when we start sampling the test plot. This particular plot has 2 different ranges of maturities in there. So we got an 85 up to about a 96 day. That was our first harvest. That was done a couple weeks ago. And then from 96 day, we went up to about 107 days. So that's kind of our later, that's what we're doing today. So we're up to that 107 day mark. So that's really kind of a review of some of the corn silage basics that we're looking at here. Yield estimates, there's a lot of great advantages to doing a yield estimate. It gives you a good idea where kind of you're at, and then just replicating that, it firms up kind of you know, a better value for you of what you have out there. And the verbiage that I like to use is it's a yield estimate. So if all the plants in the field are that same size, that's what the yield would be today. If all the plants were that same size, in that, you know, and that's why we like to repeat and replicate. So that's a Latham high-tech seed. Here we're on the acre with Latham high-tech seed. So we're going to set the sample on the scale. We want to make sure the scale is zeroed out and that there's no leaves or anything hung up. We'll record the gross weight of the 4 plants that we have on the scale. Then we'll remove the 4 plants and set them on the table. And the one that I identify, I put the label in here, I'll take out. And this will be the one that we used for the quality sample. So we'll set that on the tarp here so it doesn't get any dirt or anything on the sample. Now we'll perform the grain to stover ratio estimate. So we remove the grain off from the 3 remaining plants. We'll remove that and we'll set it up on here and we'll weigh that. And we'll look at the milk line and see where, just roughly where the milk line is at. So we're at a half milk line here, as you can see, and that is where we want to be at with kernel development to get the optimum 65 to 70% whole plant moisture for corn silage harvest. So the remaining plants, the remaining 3, just the stover component, we'll weigh that and record. And then we'll discard the remaining 3 plants. Okay, so now we're going to do the quality sample, and we're going to just chip it up, and then we'll vacuum seal it here in just a moment. So we got the ID tag on here, and then we'll run it through the chipper, bag it, and then put it in a tote here, and then we'll chip all these up and then vacuum seal them. The thing to make sure is that we put the label in the right tote. That's very important. So now the next step in the process is we're going to actually put the sample in a vacuum seal bag. We'll label it, make sure to label it with the sample number and the location. That's really important. And then we allow this to vacuum seal or to ensile for 21 days, and then we send it to the lab for evaluation. So now we'll load the sample into the vacuum seal bag. Make sure that we don't lose any of the components. And that make sure that all of the sealing area is clear of any debris, that the bag is properly labeled. Make sure we got a good seal, and then I press down on it. It kind of helps get some of the air out, and then it vacuum seals up really nice, as you can see. And while that's vacuum sealing now, I'll start packaging the next sample here. 5199. Okay, so we're going to sample for a moisture here in the field, so we kind of know which area of the field that we got this from. One of the things that's different about the way I do a moisture evaluation is that I use one plant, and what's really important about that is that we get the grain to stover ratio that this plant has intended. Just as a review, the plant, the starch here in the kernel is actually what changes the moisture. It has the largest effect on the moisture. So when we're doing a blended sample, so if we had several stocks here and we were blending that together, that could have a different impact, so our moisture wouldn't be as accurate. So I tend to want to do one plant with this grain to stover ratio, mix it up really good, and then repeat it a couple different areas of the field, that same style. So the next step then is we'll chip this up, we'll blend it, and then we'll put 100 grams in our Coster cooker kettle here. So we have the sample here that we'll actually take the 100 grams out of, so we want to mix it up really good. And you see that we have a really nice blended sample here. So we'll come over to the scale here and we'll record the kettle weight, which is 178 grams. So that's our current weight on the kettle. So I'm just kind of write that down. So then I'll just add 100 grams of this sample into that. So it should be 278. Okay, so we're at 278, and we'll put it on here, and we got this going. So we'll dry this, and I keep it pretty simple. So I just put 278, and then there's a lot of different methods. Everybody has a little bit different way of doing it. I just, because we are busy and doing other things, I'll just set this aside and just let it cook for about 25 minutes to a half an hour. So, and then I'll reweigh it after about a half an hour. We'll look at this moisture after about a half an hour. We'll do the math on it, and then we'll put it on. And sometimes if it's still drying down quite a bit, I'll put it on for another 5 to 10 minutes, and then I'll see if there's any change in the weight. And we just keep doing that until there's no more change in the weight, and then that's our final weight. And then we just do the subtraction and the math on this, and that'll give us the percent moisture in the field at that stage, or in that area of the field. So, and again, as a review, one of the important components to think about is repeating this. And then the other thing is the variability through the field. So if this test, if it's only about a quarter milk line, so from dent to about quarter milk line, you're going to gain, with the chopper in the field, you're going to gain, some people will gain up to 3 to 4%. It just depends on how much variability you had at emergence and how much variability there is in the field. But as that milk line drops, we tend to not see as much variability, so the chopper will pick up maybe a point to 2 points. So, and then as a review, corn silage on a real dry day with a lot of good moisture in the soil and good nutrients, will drop probably about a half a point of moisture a day. It can change. Sometimes if we got a really hot sun and it's a really drying day, we can see almost a point of moisture drop. So almost a point of moisture drop that in a day. So that's just something to think about as a review. So. And that's kind of a quick moisture check. One more thing. So I had some field days and some burn down days for corn silage. I'll do a moisture demonstration, just the difference between, I'll remove the ear completely, and then we'll check the moisture on just the stalk alone. And just as a review, that's going to be right around that high 70s to 80% whole plant moisture, typically a nice healthy plant will be. And then I'll add in one with just the ear that the plant had on it. And then I'll do another demonstration and I'll add one with 2 ears on it. And the reason I do that is to show why it's important to do just the one plant with that grain to stover ratio. Because when we add that second ear in, when we blend from several different areas of the field, I should say, when we do that blending, that grain to stover ratio we don't know, and it could have a lot more starch in it than what this plant really has, and so we could have an inaccurate moisture. So it's kind of important to actually do one plant and then just take that 100-gram sample that we use on the Coster cooker here from that plant and do an assessment, and then repeat that over just the area of the field, so to get your really good average of your whole plant moisture. So that's it.